Hi friends, this is Sirisha, Assistant Professor in Mathematics, Department of SNH, Chevrolet Engineering College. In past lecture, I learnt about finite differences like forward difference, backward difference, central difference and their difference tables, symbolic relations and separation of symbols, relation between operators. So now in this video lecture, we are going to discuss about Newton's forward interpolation formula and problems, Newton's backward interpolation formula, Gauss forward interpolation formula, Gauss backward interpolation formula, Lagrange's interpolation formula and problems. So first of all, what is interpolation? So it is the technique of estimating the value of a function for any intermediate value of a independent variable. So if we consider the statement y is equal to f of x, we can find the value of y. We can find the value of y corresponding to every value of x in the given range is called interpolation. We can find the value of y corresponding to every value of x in the given range of x is called interpolation. So interpolation divided three parts. Given argument values are equally spaced. Under this we have two methods, Newton's forward interpolation and Newton's backward interpolation. And given argument values are unequally spaced. In this we have Lagrange's interpolation formula, and given argument values are central values. Here we have two methods, Gauss forward interpolation and Gauss backward interpolation. So first of all, interpolation for equally spaced points. So let x0 comma y0, x1 comma y1 and so on xn comma yn be the given points with xi plus 1 is equal to xi plus h, I is equal to 0 comma 1 comma 2 and so on n minus 1. So the basic concepts of difference operators. Forward difference operator formula is f of x plus delta f of xi is equal to f of xi plus h minus f of xi. Backward difference operator nabla f of xi is equal to f of xi minus f of xi minus h. Central difference operator delta f of xi is equal to f of xi plus h by 2 minus f of xi minus h by 2. Shifting operator E f of xi is equal to f of xi plus h. So first method, in equally spaced interval, Newton's forward interpolation formula. So statement is, if x0 comma x1 x2 and so on xn are given set of observations with a common difference h. So here h is interval difference, and let y0, y1, y2 and so on yn are their corresponding values, where y is equal to f of x be the given function. Then y is equal to f of x. Then y is equal to f of x. The representation of y of x is also yx. The representation of f of x is also yx. Okay. So y is equal to f of x, that is equal to f of x0 plus ph, that is equal to y0 plus p delta y0 plus p into p minus 1 by 2 factorial delta square y0 plus p into p minus 1 into p minus 2 by 3 factorial delta cube y0 plus and so on, plus p into p minus 1, p minus 2 and so on p minus n minus 1 delta power n y0 by n factorial and so on. So here delta y0 is first forward difference, and delta square y naught second forward difference, and delta cube y naught third forward difference, and so on. So in difference table, the first values of the table we are consider in this formula, we are substitute in this formula. So delta y naught, delta square y naught, delta cube y naught. Okay. Problems. State appropriate interpolation formula which is to be used to calculate the value of exponential 1.75 from the following data, and hence evaluate it from the given data. So in this problem, here not mentioned which formula is to be applied. So how can we apply formula? So either it is Newton forward or another method Newton backward. So here given function is exponential of 1.75. So we observe tabular values for given arguments for x is 1.7, 1.8, 1.9, 2.0. So between the difference of two arguments is equal. So here the given arguments are equally spaced. So when the given arguments are equally spaced, we have to substitute two methods. In that, first one is Newton's forward interpolation. So in this problem, we have to find exponential of 1.75. So here 1.75 is lies between 1.7 and 1.8, means Newton forward difference formula is applied when the required point is close to the starting of the table. Required point is close to the starting of the tabular values. Okay. So entries of given argument y is equal to e power x, the value of e power 1.7 is 5.474, and the value of e power 1.8 is 6.050, the value of e power 1.9 is 6.686, and the value of 2 e power 2 is 7.389. This is given data. So now we have to find the value of exponential 1.75 using the formula Newton's forward interpolation formula. So first we have to calculate difference table for given data. So we enter the given arguments for x 1.7, 1.8 and 1.9, 2.0, and entries for y 5.474 and 6.050, 6.686 and 7.389. So first forward difference value is, so how 6.050 minus 5.474 is equal to 0.576. So what is the formula for y1 minus y0? That is equal to 0.576. y2 minus y1 0.636, y3 minus y2 0.706. So second difference values, delta y1 minus delta y0 0.060, delta y2 minus delta y1 0.067. So here it is delta square y0 value and this is delta square y1 value. So the difference of these two values is equal to delta cube y0. So 0.007. This is difference table for the given data. Now in this table we have the values. y0 is equal to 5.474, delta y0 is equal to 0.576, delta square y0 is equal to 0.060, and delta cube is equal to 0.07, and interval difference h is equal to 1.8 minus 1.7 value is 0.1. So the interval difference between the argument values is 0.1. Okay. So in formula we substitute the starting values of the table like this way. So let given function y is equal to e power x, then we have x naught value 1.7 and their interval difference 0.1 and finding value 1.75. So x is equal to x naught plus ph. From this we find p value. So p is equal to 0.5. So we know the value of x naught and interval difference. From this relation we get the value p. So p is equal to 0.5. So here 1.75 is our required value. Okay. By Newton's forward interpolation formula, what is the formula? Y is equal to f of x. So here x value is equal to x naught plus ph. Okay, that is equal to y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 into p 3 factorial delta cube y naught plus and so on. So here x naught plus ph is equal to 1.75. Our required value f of 1.75 is equal to, so y naught value from the difference table 5.474 plus p value 0.5 into delta y naught value 0.576. We substitute these values delta y naught, delta square y naught, delta cube y naught values from the difference table and we substitute the values. So that is equal to 5.474. We simplify this plus 0.288 minus 0.0075 plus 0.004375. So we simplify these values, we get the value 5.7549375. Rounded this value, rounded up to 4 decimals, we get the value 5.7549. 5.7549. This is our required value for 1.75. Okay. Next problem. Applying Newton's forward interpolation formula, compute the value of square root of 5.5. Given that root 5 is equal to 2.236, root 6 is equal to 2.449, root 7 is equal to 2.646 and root 8 is equal to 2.828. Correct up to 3 decimals, 3 places of decimal. Correct up to 3 places of decimal. So in this they mention the method what we have to apply. So Newton's forward interpolation, and also given function is of the form square root of 5.5, means given function is of the form root x. In this x value is 5.5. This is our required value. So given arguments is also in the form root 5 is equal to 2.236, means 5 is our argument and 2.236 is entry for this argument. So let f of x is equal to, the function is of the form root x, the difference table, consider the difference table, enter the arguments and entries. So for x given values are 5, 6, 7, 8 and for y the given values are 2.236 and 2.449, 2.646 and 2.828. So this value is equal to x naught, x1, x2, x3. Here corresponding values of y are y naught, y1, y2, y3. So their first forward difference y1 minus y naught is equal to 0.213, y2 minus y1 is equal to 0.197, 2.828 minus 2.646 is equal to 0.182. So 0.197 minus 0.213 is equal to minus 0.016. So 0.182 minus 0.197 is equal to minus 0.015. So second difference values are delta square y naught is equal to minus 0.016 and delta square y1 is equal to minus 0.015. So the difference value delta cube y naught is equal to 0.001. This is the difference table for given data. So in this the values of y naught are 2.236 and the delta y naught value is 0.216 and delta square y naught value is minus 0.016 and delta cube y naught value is 0.001. Now we substitute these values in Newton's forward interpolation formula. Before that, the interval difference of given arguments are h is equal to 1 and x value is 5.5. Using these values we find p value. So we have initial value x naught is equal to 5 and interval difference h is equal to 1 and p is equal to 0.5. By Newton's forward interpolation formula, the formula is y is equal to f of x y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 by 3 factorial delta cube y naught plus and so on. So our last value is delta cube y naught from the table. So up to that we apply formula. Okay. So we substitute y naught, delta square y naught and delta cube y naught from the table. We consider these values from the table. So the values are f of 5.5. This is our required value, that is equal to 2.236 plus 0.5 into 0.213 plus 0.5 into 0.5 minus 1 by 2 factorial into delta square y naught values minus 0.016 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 by 3 factorial. So delta cube y naught value is 0.001. So 3 factorial means 6. So we simplify this value, we get the value 2.3445625. Rounded up to 3 decimals, we get the value 2.345. This is our required solution for the value square root of 5.5. So one more problem. Using Newton's forward interpolation formula and the given table of values. So here given arguments for x 1.1, 1.3, 1.5, 1.7, 1.9. So here we observe that the difference is 0.2, 1.1, 1.3, 1.5, 1.7, 1.9. So h is equal to 0.2 and their corresponding values for y naught is equal to 0.21, y1 is equal to 0.69 and y2 is equal to 1.25, y3 is equal to 1.89 and 2.61. So obtain the value of f of x when x is equal to 1.4. So at what point we find the value at x is equal to 1.4? We have to find the corresponding value of y. Okay. First we consider the difference table for given data. So x values here, x naught is equal to 1.1, x1 is equal to 1.3, x2 is equal to 1.5 and x3 is equal to 1.7, x4 is equal to 1.9. The corresponding values of y naught is equal to 0.21 and y1 is equal to 0.69, y2 is equal to 1.25, y3 is equal to 1.89, y4 is equal to 2.61. So their first forward difference values are y1 minus y naught 0.48, y2 minus y1 0.56, y3 minus y2 0.64 and y4 minus y3 0.72. So here delta y naught value is 0.48 and delta y1 value is 0.56, delta y2 value is 0.64 and delta y3 value is 0.72. So second forward difference values are delta y1 minus delta y naught 0.08 and delta y2 minus delta y1 0.08 and delta y3 minus delta y2 0.08. So the third difference values, the second difference values are all same. So from that, third difference values is equal to 0. So here y0 value is 0.21, y1 value is 0.48, delta square y0 value is 0.08. Okay, we substitute these values in formula. Before that, if we take x0 is equal to 1.3, then y0 is equal to 0.69, delta y0 is equal to 0.56, delta square y0 is equal to 0.08, delta cube y0 value is 0. So h is equal to interval difference 0.2 and x is equal to 1.3. So we have x0 plus ph is equal to 1.4. From this, p is equal to 1 by 2. So using Newton's interpolating formula, we substitute these values in formula. We get the value at x is equal to 1.4, y is equal to 0.96. This is our required value. Okay. So next, equally spaced interpolation formula is Newton's backward interpolation formula. Newton's backward interpolation formula. So statement is, if x0, x1, x2 and so on xn are given set of observations with common difference means interval difference is equal between arguments, and let y0, y1, y2 and so on yn are their corresponding values, then where y is equal to f of x be the given function, then what the formula is, f of xn plus ph, f of xn plus ph. This means this value is equal to y f of y of xn. This value is equal to y of xn. So that is equal to f of xn plus p nabla f of xn plus p into p plus 1 by 2 factorial nabla square f of xn plus p into p plus 1 into p plus 2 by 3 factorial nabla cube f of xn plus and so on, plus p into p plus 1, p into p plus 2 plus and so on, p plus n minus 1 by n factorial nabla power n f of x power n. This is the formula for backward interpolation formula. Here f of xn is initial value, end value in entries, and nabla f of xn, nabla square f of xn, nabla cube f of xn values we consider from the difference table. So when we apply this backward interpolation formula means, when the required point is close to the end of the tabular values, when the required point is close to the end of the tabular values, then we apply Newton's backward interpolation formula. And this we consider from the tabular values, we consider last values of the table, Okay, so when we apply this formula, the required point is close to the end of the table or terminal values. So problem, the following data given, the values of y are consecutive terms of which is 23.6 is the sixth term. Find the first and 10th terms of the series. So in this problem, we have to find first value and end value. So here first value and end value 10, and first value we have to find sixth term 23.6 is the sixth term. Find the first and 10th terms of the series. We using to find first term Newton's forward difference formula, and to find last term using Newton's backward difference formula. Okay, so for given data, the interval difference is equal. So here the arguments are 3, 4, 5, 6, 7, 8, 9, and their corresponding values are 4.8, 8.4, 14.5, 23.6, 36.2, 52.8, 73.6. Since we require the value of corresponding to a value of x near the end of the table, Newton's forward interpolation is to be used. So the forward table given as below. So for given values 3, 4, 5, 6, 7, 8, 9 and their corresponding values for y 4.8, 8.4, 14.5, 23.6, 36.2, 52.8, 73.9. So their difference nabla y naught value is 3.6, nabla y1 value is 6.1, nabla y2 value is 9.1, nabla y3 value is 12.6, nabla y4 value is 16.6 and nabla y5 value is 21.1. So second difference values nabla square y0 2.5, 3.05, 3.5, 4.0, 4.5, nabla cube y value 0.5, 0.5, 0.5, 0.5. In this column all the values are same, so next difference will be equal to 0. Okay, so from this table we consider the values yn is equal to 73.9 and nabla yn is equal to 21.1, nabla square yn is equal to 4.5 and nabla cube yn is equal to 0.5. So in this way we consider the values for this formula. Okay, for forward formula in this way we consider the values nabla y naught, nabla delta y naught, delta square y naught, delta cube y naught. For backward difference formula we get the values like this 73.9, 21.1, 4.5, 0.5. So backward and upward and backward direction. Okay, so here interval difference h is equal to 1 and x is equal to 1. So x is equal to 1 means the first term, so here x is equal to 1, x naught is equal to 3 and p is equal to x minus x naught by h. We get the p value minus 2. So p is equal to minus 2. We substitute these all values in the formula. Newton's forward difference formula is y is equal to f of x. Here x value is 1. So y of 1 is equal to 4.8 plus minus 2 by 1. We substitute in formula. So what is formula? Y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 by 3 factorial delta cube y naught plus and so on. So we substitute the values from the difference table. We substitute in formula. We get 4.8 minus 2 by 1 into 3.6 plus minus 2 into minus 3 by 1.2 into 2.5 plus minus 2 into minus 3 into minus 4 by 1 into 2 into 3 into 0.5 is equal to 3.1. To find this is first term in the table. So at x is equal to 1 the value of y is equal to 3.1. At x is equal to 1 the value of y is 3.1. So now we have to find last term of the table. So to find the 10th term we use Newton's backward difference formula. With xn is equal to 9, x is equal to 10 and their interval difference h is equal to 1 and p is equal to x minus xn by h. We get p value is 1. So now substitute these all values and also nabla yn and nabla square yn and nabla cube yn values in backward difference formula. So what is the formula? Yn of x is equal to yn plus p nabla yn plus p into p plus 1 by 2 factorial nabla square yn plus and so on. So here x value is 10. So y of 10 is equal to yn value 73.9 in plus p value 1 by 1 into nabla yn value 21.1 plus 1 into 1 plus 1 2, 1 into 2 by 2 factorial into 4.5 plus 1 into 2 into 3. So means p into p plus 1 into p plus 2 by 3 factorial into 0.5. We simplify these values, we get the value 100. So at x is equal to 10, the value of y is 100. So at x is equal to 1, the value of y is 3.1. So the first value of the table is 3.1 and end value of the table value is 100. So hence the solution. Another problem, find the value of y from the following data. X is equal to 0.47. X is equal to 0.47 and given data, tabular data is for x 0, 0.1, 0.2, 0.3, 0.4, 0.5. So y 1.00, 1.1103, 1.2428. So 1.3997. At x is equal to 0.4, y value is 1.583. At x is equal to 0.5, y value is 1.7974. So in this problem, they are not mentioned the method, which formula we have to apply for given data. So in this type of problem, first we check the given data is equally spaced or not. So here the given arguments are equally spaced arguments, means their interval difference is same. So now we have two methods, Newton's forward and Newton's backward. So in those, what we have to apply? So at x is equal to 0.47. So in this problem we apply Newton's backward interpolation. Why? Because the required point is close to the end of the tabular values. So now we apply Newton's backward interpolation formula to find required value. So solution, since we require the value of corresponding to a value of x near the end of the table, so we apply Newton's backward interpolation formula is to be used. The backward table is given as follows. So the given arguments are 0.0, 0.1, 0.2, 0.3, 0.4, 0.5 and their corresponding values of y is 1, 1.1103, 1.2428 and 1.3997, 1.5836, 1.7974 and first backward difference nabla y0 value 0.1103, 0.1325, 0.1569, 0.1839, 0.2138. So how we get these values? The difference y1 minus y0 nabla yn. So y2 minus y1 value, y3 minus y2, y4 minus y3, y5 minus y4. Similarly we get these values. So finally we have nabla power 4 y1 0.004, 0.003 and nabla power 5 y is equal to 0.001. This is very small number, so we neglect that difference number here. So coming to substitution part. Here h is equal to 0.1. So p is equal to xn minus x by h. Here xn value is last value of the table 0.50 minus required value of the given problem 0.47 by 0.1. So we get the value for p is 0.3. So Newton's backward difference formula is y is equal to yn plus p nabla yn plus p into p plus 1 by 2 factorial nabla square yn plus p into p plus 1 into p plus 2 by 3 factorial nabla cube yn plus and so on. So now we substitute the value of yn, nabla yn and nabla square yn, nabla cube yn and so on values from the backward difference table. That is equal to yn 1.7974 plus p value minus 0.3 into nabla yn value 0.2138 plus minus 0.3 into minus 0.3 plus 1 by 2 factorial 0.0299 plus minus 0.3 into minus 0.3 plus 1 into minus 0.3 plus 2 by 3 factorial 0.0029 plus minus 0.3 minus 0.3 plus 1 into minus 0.3 plus 2 into minus 0.3 minus 3 by 4 factorial into 0.003. This is nabla power 4 yn value. So we simplify this calculation by using calculator. We get the value 1.7299. So this is our required answer for given value 0.47. Okay, at x is equal to 0.47, the value of y is 1.7299. So next method is Gauss forward central difference formula. So when we apply this formula means, so most of the problems they mention the method for these two, Gauss forward and central difference and Gauss backward central difference. So in case of not mentioned, we observe central value, we consider the center value and the required point near to the central value, start of the center value, we apply Gauss forward central difference formula, and the required point is close to the end of the center value, close to end part of the center value, then we apply Gauss backward central difference formula. So first the statement is if x naught x minus 2 comma x minus 1 x naught, so here initial value x naught, before values are x minus 2 x minus 1 and after values are x1 x2. So our required value is between, here we apply Gauss forward and the required value lies between positive side, then we apply backward Gauss backward central difference. So our given set of observations with the common difference h, so h is interval difference, and let y minus 2, y minus 1, y naught, y1, y2 are the corresponding values. When y is equal to f of x be the given function, then yp is equal to y naught minus p delta y naught plus p into p minus 1 by 2 factorial delta square y minus 1, sorry, here the formula is plus y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y minus 1 plus p into p minus 1 p plus 1 by 3 factorial delta cube y minus 1. So p into p minus 1 p plus 1 into p minus 2 by 4 factorial delta power 4 y minus 2 plus and so on, where p is equal to x minus x naught by h. So first problem, use Gauss forward interpolation formula to find f of 3.3 from the following table. So most of the cases mention the method what we have to apply. Okay, so the given tabular values is, tabular data is x is equal to 1 2 3 4 5, y is equal to f of x 15.30, 15.10, 15, 14.50, 14. So the difference table for the given data is given below with x naught is equal to 3. So we consider the center value of given data, center value. So here we have 5 observations, in this center value is 3. We consider that center value is initial value x naught, so x naught is equal to 3. So the above values of center value is let me denote x minus 1, x minus 2, and below values we have to denote x1, x2. So x naught is equal to 3, and x minus 1 is equal to 2, x minus 2 is equal to 1, x1 is equal to 4, x2 is equal to 5. So our required value belong to upper part of the center value. We apply Gauss forward interpolation, and our required value belongs to below part of the center value, then we apply Gauss backward interpolation. So in case of not mentioned in problem, so sometimes they mention like use Gauss interpolation formula. In such cases we have to select what formula we have to apply, which one is we have to apply. Okay, so then their corresponding values also. For x naught it is y naught is equal to 15.0, y minus 1 is equal to 15.10, so y minus 2 is equal to 15.30. okay na. So last values are decrease, means starting value y minus 2. So first difference value is equal to delta y minus 2 and second value equal to delta y minus 1. So third value delta y naught and fourth value delta y1. So end one value decrease column by column. Okay, so in this value equal to delta square y minus 2, the order of the column is not changed. Okay na, the order of the column is minus 2 minus 1 0 1 2. Okay, so this here also minus 2 minus 1 0 1, minus 2 minus 1 0, minus 2 minus 1, finally minus 2. So the values are delta y minus 2, delta square y minus 2, delta cube y minus 2, delta power 4 y minus 2. These are the place values. The place value of this value is delta y minus 2, delta square y minus 2, delta cube y minus 2, delta power 4 y minus 2. Okay, so this one is delta square y minus 1, delta square y naught, delta cube y minus 2, delta cube y minus 1, delta power 4 y minus 2. So here x naught is equal to 3. From the table we note that y naught is equal to 15.0, delta y naught is equal to minus 0.50, delta square y minus 1 minus 0.40, delta cube y minus 1 0.40, and delta power 4 y minus 2 is equal to 0.90. So let xp is equal to 3.3. So then p is equal to xp minus x naught. So we get the value of for p is equal to 0.3. So the Gauss forward difference formula now becomes f of 3.3. This is our required value. Yp is equal to 15. We substitute these values from the table. 15.00 plus 0.3 into minus 0.50 plus 0.3 into 0.3 minus 1 by 2 factorial minus 0.40 plus 0.3 into 0.09 minus 1 by 6 into 0.40 plus 0.3. So here this is delta square y minus 1 value. Next term delta cube y minus 1 value. In this delta power 4 minus 2 value. Okay, so we substitute all values from the difference table. We simplify this calculation by using calculator. We get final value 149. The value of x 3.3, the value at x is equal to 3.3, the value of y is 149, sorry 14.9. okay, given another problem, given f of 2 is equal to 10, f of 1 is equal to 8, f of 0 is equal to 5, f of minus 1 is equal to 10, estimate f of 1 by 2 by using Gauss forward formula. So at x is equal to 1 by 2 we have to find these values, tabulating the given values we have. So f of x means y naught values. Here x is 2, 1, 0, minus 1. So we consider these arguments. First minus 1, we are arranging these values like this: minus 1 0 1 2 in increasing order, minus 1 0 1 2, and y minus 1 value, corresponding values of y are 10 5 8 10. So here our value 1 by 2, our required value 1 by 2 means 0.5. So 0.5. Okay, first we find difference of difference table. Delta, the place value, the column place value is minus 1 0 1 2. So delta y minus 1 is equal to minus 5, delta y naught is equal to 3, delta y1 is equal to 2, delta square y minus 1 is equal to 8, delta square y naught is equal to minus 1, delta cube y minus 1 is equal to minus 9. So here x naught is equal to 0 and y naught is equal to corresponding y value 5, and delta y naught value is 3, and delta square y minus 1 is equal to 8. So here we consider the values from the table like this way. Okay, 5 3 to 8, like V shape, 5 3 8. Next we substitute these values in formula. We require the value for x is equal to 1 by 2, means that is equal to 0.5. So p is equal to xp minus x naught by h, that is equal to 0.5. Using Gauss forward difference formula, f of 1 by 2 is equal to f of xp, that is equal to yp is equal to y naught plus p delta y naught plus p into p minus 1 by 2 factorial delta square y minus 1. We substitute the values from difference table. 5 plus 0.5 into 3 plus 0.5 into minus 0.5 by 2 into 8. So we simplify this value, we get 4.5. So at x is equal to 1 by 2, the corresponding y value is 4.5. So another central difference formula, Gauss backward central difference formula. So statement is, if x minus 2, x minus 1, x naught, x1, x2 are given set of observations with a common interval difference h, and let y minus 2, y minus 1, y naught, y1, y2 are their corresponding values, where y is equal to f of x be the given function, then yp is equal to y naught plus p delta y minus 1 plus p into p plus 1 by 2 factorial delta square y minus 1, p plus 1 into p minus 1 by 3 factorial delta cube y minus 2 plus p plus 2 p plus 1 p into p minus 1 by 4 factorial delta power 4 y minus 2 plus and so on, where p is equal to x minus x naught by h. So h is interval difference and x is our required value, x naught is initial value, center value. Okay, this is the formula for Gauss backward central difference. So going to problems. From the following table, find y when x is equal to 1.35. So when x is equal to 1.35, find y value. The given data for x and y is x1 1.2 1.4 1.6 1.8 2, and the interval difference is 0.2. And the corresponding values for y 0.00 minus 0.112 minus 0.016 0.336 0.992. Okay, so here our required value x is equal to 1.35. so our total observations are 1 2 3 4 5 6. So in that we consider 1.4 as center value. So the place value is x naught and x minus 1, x minus 2. So this value is x minus 2, x minus 1, x naught, x1, x2, x3. So y naught value, corresponding y naught value minus 0.016, y minus 1, y minus 2, y1, y2, y3. So their difference values, first difference value minus 0.112, 0.096, 0.352, 0.656, 1.08. The place value is delta y minus 2, delta y minus 1, delta y naught, delta y1, y2. So here delta square y minus 2, delta square y minus 1, delta square y naught, delta square y1. So this is delta cube y minus 2, delta cube y minus 1, delta cube y naught, and fourth difference values becomes 0. Okay. From the table we write the values. The interval difference is 0.2, initial value 1.4, and our required value 1.35. So from these values we get the p value minus 0.25. According to Gauss backward interpolation formula, we substitute. So what is the formula? Yp is equal to y and y naught plus p into delta y minus 1. So here delta y minus 1 value is 0.096, and delta square y minus 1 value is 0.256, and delta cube y minus 2 value is 0.048. So substitute the values from the difference table and simplify this calculation using calculator. We get the value minus 0.062125. So at x is equal to 1.35, the value of y is minus 0.062125. Okay. Another problem. Use Gauss backward interpolation formula to find f of 32 given f of 25 is equal to 0.270, f of 30 is equal to 0.3027, f of 35 is equal to 0.3386, f of 40 is equal to 0.3794. So here x values are 25, 30, 35, 40, and their corresponding values of y is 0.2707, 0.3027, 0.3386, 0.3794. We have to find y value at x is equal to 32 using Gauss backward interpolation formula. So let us consider the difference table. So here x values are 25, 30, 35, 40. We have to find the value of y at x is equal to 32. Okay. So let us consider 30 will be center value. So the place value is x minus 2, x minus 1, x naught is equal to 35, x1 is equal to 40. So we consider the center value is 35. Sorry. So and their corresponding values y minus 2 is equal to 0.270107, y minus 1 is equal to 0.3027, and y naught is equal to 0.3386, y1 is equal to 0.3794. So the first difference values are 0.032, means delta y minus 2, delta y minus 1, delta y naught. Here delta square y minus 2, delta square y minus 1. Here delta cube y minus 2 value. This is delta cube y minus 2 value. Okay. So these are delta y minus 2, delta square y minus 2, and delta cube y minus 2. So from the table we find that y naught is equal to 0.3386, delta y minus 1 value is 0.0359, delta square y minus 1 value is 0.0049, delta cube y minus 2 is equal to 0.0010. From this we find p value, p is equal to x is equal to 32, then p is equal to minus 0.6. Substitute all these values in Gauss backward difference formula. F of 32 is equal to 3386 plus minus 0.6 p value, p into delta y naught value. So p into p minus 1, p plus 1 by 2 factorial 0.0049. This is delta square y minus 1 value plus p into p minus 1 by 3 factorial means 6 into delta cube y minus 2 0.0010. So we simplify all this value using calculator. We get the value 0.3165. So at x is equal to 32, the corresponding value of y is 0.3165. Okay. So another method, Lagrange's interpolation formula. This is coming under unequally spaced interpolation. Given values or given argument values are unequally spaced, then we apply Lagrange's interpolation formula. So statement is, if x0, x1, x2 and so on xn are given set of observations which are need not be equally spaced, and let y0, y1, y2 and so on yn are their corresponding values where y is equal to f of x be the given function, then the formula is f of x is equal to x minus x1 into x minus x2 and so on x minus xn by x0 minus xn, x0 minus x2 and so on x0 minus xn into y0 plus x minus x0 into x minus x2 and so on x minus xn by x1 minus x0, x1 minus x2 and so on x1 minus xn y1 and so on x minus x0, x minus x1, x minus xn minus 1 by xn minus x0, xn minus x1 and so on xn minus 1 into yn. This is the formula for Lagrange's interpolation formula. So when we apply this Lagrange's interpolation, the given argument values are unequally spaced. Then we apply Lagrange's interpolation formula. So first problem, given the values x is equal to 0, 2, 3, 6. So here we observe that the difference is of each argument is different. So in first case 0, 2, 2, 3, 3, 6. So unequally spaced interval. So f of corresponding values of y is minus 4, 2, 14, 158. Using Lagrange's formula for interpolation, find the value of f of 4. So at x is equal to 4, we find the value of y. So using interpolation formula, f of x is equal to, so this is the formula for Lagrange's. So here we substitute. From this table, x0 is equal to 0, x1 is equal to 2, x2 is equal to 3, x3 is equal to 6, and y0 value minus 4, y1 value 2, y2 value 14, y3 value 158. We substitute these values in this formula, and x value is required value. At x is equal to 4, we have to find y value. So x value is 4. We substitute all these values in this formula. So x is equal to 4, x1 is equal to 0, x2 is equal to 2, x3 is equal to 3, x4 is equal to 6. So f of x1 is equal to minus 4, f of x2 is equal to 2, f of x3 is equal to 14, f of x4 is equal to 158. So at x is equal to 4, y is equal to 4 minus 2 into 4 minus 3, 4 minus 6 by 0 minus 2 into 0 minus 3 into 0 minus 6 into minus 4. Plus we substitute all values. Okay, so we simplify this, we get the value 40. So at x is equal to 4, the corresponding value of y is 40. So the values of x and log x are 300, 2.4771, 304, 2.4829, 305, 2.4843 and 307, 2.4871. Find the log 301. So the given values are in like ordered pairs. So function is log x base 10 and corresponding x values are 300, 304, 305, 307, and we have to find y value at x is equal to 301. So in this, x naught is equal to 300 and x1 is equal to 304, x2 is equal to 305, x3 is equal to 307, and y naught is equal to 2.4771, y1 is equal to 2.4829, y2 is equal to 2.4843, means f of y naught. So y3 is equal to 2.4871. So by Lagrange's interpolation formula, so formula is f of x is equal to x minus x1 into x minus x2 and so on x minus xn by x naught minus x1, x naught minus x2 and so on x naught minus xn, f of x naught plus and so on x minus x naught into x minus x1 into and so on x minus xn minus 1 by xn minus x naught, xn minus x1 and so on xn minus xn minus 1, f of xn. So the given function is log base 10 301 is equal to, so x minus x1, so x value is 301 minus x1, so value is minus 3, x1 is 304, so it's minus 3 into minus 4 into minus 6 by minus 4 into minus 5 minus 7 into f of x naught value 2.4771. So similarly we substitute all values and simplify this. We get the value, final value 2.4786. The value at x is equal to 301. The corresponding value of y is 2.4786. So thank you.